so when we look at this problem, number 84. When we look at this problem, number 84. All right. Can't see what these are. The distinctive odor in vinegar is due to acetic acid. Now there's supposed to be an H right there. There's a typo. Okay? Due to acetic acid, which is this, which reacts with sodium hydroxide according to the equation. Now there are 3.45 milliliters of vinegar. So we have 3.45 milliliters of this. Reacts with 42.5 milliliters of this, but it tells us that it's 0.115 molar. Okay? Now when it talks about reaching the equivalence point, what that means is equal, that the moles of this equals the moles of that. That's what the equivalence point means. That means, in other words, the reaction is done. Okay, so you have just the right ratio. How many grams of acetic acid? So this is the question for how many grams of acetic acid. Okay? Now it's real important to know what you're looking for. Because if you don't know what you're looking for, you're probably never going to find it. Okay? But it doesn't just want how many grams, it wants grams that are in 1 quart, so it's going to be grams per quart. Okay? So that's what I'm looking for. This is my unknown. This is part of the unknown, so I know I'm going to want to start with this. This is my given. Okay? So I need to find out how many grams there are, so I'm going to have to take my milliliters to moles, to grams. And that's how many grams will be in 3.45 milliliters. So then what will we need to do? Convert what? Convert it to quarts. And this would be given to you that 1 liter is 1.057 quarts. You're never going to be expected to know English to metric conversions. They'll always be given to you. Okay? So, again, capital M, what does capital M stand for? Molarity, but what are the actual units on it? Moles per liter. So this is really moles per liter, which makes that the conversion factor. So I'm going to want to start with this, my simplest unit. Because this is moles per liter, I need to change this to liters. We do this in our head. How do we change milliliters to liters? Divide by 1,000. So somebody else, what does that mean about the decimal point? We're going to go back how many places? 3 places. So it's going to be 0.0425 liters of NaOH. Okay? Now I'm going to use my molarity to convert that to moles. So it's going to be 0.115 moles for every 1 liter. Okay? So liters cancel. That tells me how many moles of sodium hydroxide it took to neutralize the acetic acid. It's a 1-to-1 ratio. 1 mole CH3 COOH for every 1 mole NaOH. Moles of NaOH cancel, so if I stopped right there, I got moles of acetic acid. What do I do next? You guys have to understand, I mean, you're just mumbling, okay? Okay, that was kind of a big jump right there. What are we looking for first? Grams. So what's the next step just to find grams here? Convert it to grams using the molar mass. So you add all this up, it comes out to 60.06. Okay? So I would go ahead and get an answer right there. Now you can do it all in one step if you want to just keep going. A lot of people did that in the other class. Just kind of keep going. But I'm going to break it up into 2 steps. Okay? So what does this grams come out to? Anybody get an answer?
I got it,
0.294. Okay? But how much is this, what volume is this 0.294 grams in? In 3.45 milliliters. So what we have right now is we have 0.294 grams over 3.45 milliliters. But we need grams per quart, so what do we have to do now? Convert the liters to quarts, so we have to change this. Now, if you want to do this in your head ahead of time, you can move that, but we can just go times, how do we change milliliters to liters? 1,000, so there's a, not you multiply in this case, well, you would divide milliliters by 1,000, but to make the units here, we're gonna go this way. Because milliliters cancel, so that leaves me with grams per liter, but I need grams per quart, so I'm gonna go times 1 liter over 1.057 quarts. And that's gonna equal A1. 80.6. So if you have a quart of vinegar, you probably have 80.6 grams of acetic acid actually in it. It's about 5%. We're actually going to do a lab at the end of the year when we do acids and bases, where we actually find out what the molarity is. And if you had Graver, you probably did that. Also, what's the molarity? And we're going to go with the mass percent. What's the mass percent of vinegar? We'll compare Great Value to Heinz or some name brand vinegar and just see if there's any difference between the generic and the real deal. I know that's something you can't wait for. Now, in terms of labs as well, I want us to do a stoichiometry lab, and I have one. We're going to make potassium trisoxylalloferrate 3-trihydrate, a pretty green crystal. Okay? Part of the lab report is going to be you being able to verbally say what the name is, because it's a mouthful. Potassium trisoxylalloferrate 3-trihydrate. It'll be nice to go home and tell your parents, hey, we made some potassium trisoxylalloferate 3-trihydrate today in class. Oh, well, that's nice. But they'll sound like they're getting their money's worth out of it, you know, if you take an AP chemistry. All right, but I'm waiting on that for the Hoover City Schools to make a decision on, are we going 5 days or not? Okay, because it would be a lot easier if everybody was here, you know, and we weren't staggered schedule, and then we could just do the lab. So if we go to 5 days, we're going to do the lab like on Monday, and I'll send out a remind and let you know as far as bring your lab manual, dress appropriately with long pants, closed-toe shoes. Okay? If they can make the decision before Thursday, okay, we'll do the lab on Thursday and Friday, depending upon what day you're here. You guys would be Friday, okay? And then you'll work on just practice problems on the day before, okay? We are actually probably, and what I may do is, well, I don't know if I want to do that because that's going to leave it out there. Well, we need to have a quiz over just stoichiometry and solutions, limiting reactants. And I haven't talked about percent yield yet, but that's super easy. As a review, we did percent yield all in chemistry 1, and that's just what you got over what you should have gotten. That's coming up too. So we have to I just got to get, again, it's hard for me to plan when I don't know what I'm planning for, as far as, am I planning for every day? Am I planning for half virtual? What the deal is, so. having a quiz. Today's Tuesday. We're pretty much done with all new material for what I would want to test you on, which would be just doing straight up stoichiometry problems, limiting reactant, how much excess reactant is left, and then how to calculate molarity, and we're gonna do all of that kind of today. All right? So, on this particular problem, the most important thing is to know what you're looking for. Okay? Because then it's just conversions. Almost everything in chemistry is a conversion. Just knowing which one to use is the trick. But I know that whatever's here has to be on the bottom here. Whatever's here has to be on the bottom there. Since this is moles of NaOH, I have to have moles of NaOH. Okay, I get grams. I'm looking for grams per quart. So I have to, just take what I'm given and try to just get everything to the appropriate unit. Okay? So that's kind of the key point on this one. All right, we're going to do a couple more practice, but before we do that, I want to stress one other thing. If I have a substance like magnesium chloride, okay, and I put that into water, how is it going to dissolve? What particles? Give you a word. It's going to dissociate. What does that mean?
Separate.
Say that again.
Separate.
Separate or separate. Okay? So what's that going to, what are the two ions present in magnesium chloride? Magnesium and chloride, not chlorine, Cl2. It's going to be chloride because that's the ion. And so this really is an Mg2+ attached to a Cl- attached to a Cl-. Right? But when you put an ionic compound into water, it's going to break apart into individual ions. It's not going to break apart as an NaCl. It breaks apart as an Na+ and a Cl-. It dissociates as ions. Ionic compounds, this is deep here, stay with me. Ionic compounds are composed of ions. Okay? That's deep. Ionic compounds are composed of ions. So when they dissolve as ions. They don't make molecules, they dissolve as individual ions. So you always have in an ionic compound, a metal and a nonmetal, it's going to dissolve as ions. So what's this going to break up into? Mg2+ and what?
Plus chlorine.
Is it going to be Cl2?
No.
Because what's the ion? Will two negative things bond together? No. So we're going to get, this is kind of like the short answer question, we're going to get two Cl-. Because it's going to break here, it's going to break here, the water is going to come and surround this one, water is going to come around surround this one, and water is going to come and surround this one. So we'll end up having a Cl-, and an Mg2+ ions in solution. So the one particle is going to break up into three when it dissolves in water. It's going to dissociate. So if I make a 1 molar solution of this, what's my ion concentration actually of Mg2+ going to be? For every one of these, how many of these do we get? One. So if this is 1 molar, what's that going to be? 1 molar. But what's this going to be? 2 molar. Because for every one of these, you're going to get 2 of those. So the reality is the total ion concentration is going to be 3 molar. Because each particle is going to break up. You're measuring how many moles of this you put in, but it really breaks apart into much smaller pieces. But we're going to get 3 moles for every one we put in of particles. But it's just the coefficients. So whatever this kind, we always measure when we do the molarity in terms of this, but we have to be aware of how it's going to break up in the solution here. Okay? So if we said, okay, when, I'm just gonna make up something, 15 grams of silver chromate are dissolved into 250 milliliters of water. I really worded that wrong. I really need to say, dissolved in enough water to make 250 milliliters because it's volume of solution. Okay, but we're gonna say this is the volume of the solution. Are dissolved in 250 milliliters of water. What are the concentrations of Ag plus and CrO4 2 minus? Okay, now, another tidbit. Brackets mean molarity. Whenever you have brackets around something, it means the concentration of that thing in molarity. So what do we need to do on this? Write the equation. So Ag2, CrO4 solid, what's that going to dissociate into? What's the charge going to be on Ag? And again, it's going to dissolve as ions. By definition, an ion is a charged particle, so you have to have the charge on it. Ag is +1, so we're just going to get one of them. Is it going to be a subscript 2 or coefficient 2? Coefficient 2, because the two positive things are not going to bond together. They're each going to get surrounded by water. You're just going to get two separate, so it's going to break up into two Ags. And what's the other ion? How many of those are we going to get? Just one. Okay? So now what? Okay? Calculate the molarity of this thing, which is going to be 15 grams divided by what? What do we have to calculate?
Is the 250 the whole solution, or is it just?
15 grams of silver chromate.
Yeah.
So I know that that's how much of this I put in, and I know that the volume is going to be 0.250 liters. But how do I need moles per liter? How do you take grams to moles? Okay, the molar mass, right? So we got to figure that out. So if someone's got a calculator, I'm going to call some numbers out to you, so add them up. So silver is 107.9 times 2 plus 52 plus 64. 331.8 grams per mole. Okay? So now just go 15 divided by 331.8 divided by 0.25. And we get this divided by this divided by this. Alright, so Zoe can see the final answer. 0.1808.
Yes.
Say 181.
Taylor Moore, please
Molar.
come in front desk. Taylor Moore.
So if this is 0.181 molar, what's this one? 2 times that, right? So 362. And what's this one going to be? 0.181. Okay, so when we want the individual ions, you just have to know how it's going to break up. Okay, and then you have to calculate the concentration of the main thing, and then just how's it going to break up. It's always going to be a whole number multiple of whatever you calculate, because you don't get parts of ions. All right, so we good with that? All right, so you get 5-minute break. So this is where you get to walk around, go to the bathroom, call your mom. Well, text your mom. We're not allowed to call. How come no one ever texts the dad?
I don't know.
Always text your mom. She's the one that's going to take care of you. Dad's just going to complain. Why didn't you bring it yourself?
Yeah, something like that.
Those of you at home, you can fast forward the next 5 minutes. I can't stop it because then it'll be 2 files. You wanna sign up?
Yeah.
No, this is
Oh,
first
we
time,
actually
right?
signed up for it.
Okay, so.
What's the worst way to do it? Think about it. It would be kind of fun.
What's your name?
Person, I guess we just go to bowling with people in this molar.
I don't really
Should we
know.
go bowling soon?
What you're
See if we're good at it.
Yeah, you haven't been
Okay.
before?
Gonna watch some YouTube videos. How to bowl. We'll bring you some.
Okay, so what you need to do is make sure you get a physical.
And up to date.
And up-to-date consent. Okay? So have those two things to me, you can bring them to me beforehand, or you can bring it to me the day of the morning, you can just come to Old Mountain Lane.
Yeah, I know where that is.
Okay, you just come right after school, get there when you can, class close to 4 as possible.
Alright, but I might be busy, but
Well, I mean, that's where you're gonna have to make a decision on what, you know, cause you gotta be there for trials on those, you know, at least 2 or 3 days. Okay? Just do
and
that.
by the way, there's no funeral.
Oh, just Thompson.
Yeah, just Thompson.
Okay.
Nice.
That thing, correct.
Alright.
Right, it's a lot, huh?
Not rolling. So, when are bowling tryouts?
October 5th through the 7th.
Alright. You'll be there.
Bowling tryouts, October 5th through the 7th.
I hope you make it too.
And we don't bowl with the bumper guards up.
Oh man, that's a handicap.
Yeah, you gotta throw it down the middle. Gutters count, and
Yeah, this.
I'll just make one gutter every 5 holes.
okay, that was the probably that one. Okay,
Extend it.
now I want to give you a chance. I should have stopped it. Let's look at the next one. And it kind of goes up onto the next page, on the next column, I should say. Okay? But it says a 4.36 gram sample of an unknown alkaline metal hydroxide. That means the lithium hydroxide, a sodium hydroxide, a potassium, some alkaline metal hydroxide, is dissolved in water. And a hydroxide, just as a refresher, that's gonna make it a base. Opposite of an acid. Positive thing being hydrogen is an acid, when the negative thing is a hydroxide with a metal, it's a base. Which is why the group 1 are called alkali metals, because alkali means basic. So the alkali hydroxides, those alkali metal hydroxides, are very, very strong bases. Okay? So, dissolved in 100 milliliters of water, an acid-base indicator is added and the resulting solution is titrated. That just means that the two liquids are mixed together with 2.5 molar HCl. The indicator changes color when and you guys, we did that in chemistry 1. You add the acid until it changes color, and that tells you the equivalence point when the reaction is done, when you have exactly the same moles of acid and base. Okay, so that always just tells us, hey, the reaction's done. Okay? 17 milliliters of hydrochloric acid was used. What is the molar mass of the, and it goes on to the next thing, of the unknown alkali metal? Okay? So what do we think we should do probably to start with? What should we do to start with? Not a clue? What? Well, even before then. in this problem, isn't it?
Find the molarity of alkaline.
Okay, but that's going to be, you know, we wanna get to there, but we need to write a balanced equation first. Whenever you have stoichiometry, get a balanced equation, then we can list what we're given and what we're looking for. So what's reacting with what? So you have the metal hydroxide. Now what's the charge on all alkali metals? +1. So I know it's just MOH, some alkali metal, OH, plus HCl, and that's going to go to the metal chloride and HOH, which is water, H2O. So you're going to get that metal chloride plus, and I like to write it as HOH, just because it's the H plus and the OH minus combined. It's the exact same thing as H2O, so whichever one floats your boat the most, you can do it either way. I just think in an acid base, writing it as HOH just makes more sense, that it's the H plus from the acid combining with the OH minus from the base to make HOH. Water. Okay? Now, I am given 17 milliliters of HCl. And it tells me that it's 2.50 molar. Right? And I know that I have 4.36 grams of this. Now the question says, what is the molar mass of the unknown metal? Okay? Well, what is molar mass? Grams per mole, right? Well, in every mole of MOH, how many moles of the metal do I have? So if I know how many moles of this I have, I can know how many moles of M I have. Right? Because it's 1 to 1. If this was M2OH, then we'd have 2 moles of M for every 1 mole of MOH. Okay? But because it's 1 to 1, or however many moles of this there are, that's how many moles, because the subscript is a 1. So what can I do? Okay? So I start with what? What should I start with? Come on, stay focused, everybody. What should I start with? Molarity times volume equals moles, right? It's 1 to 1, so if I know how many moles of this, I know how many moles of that, which means I know how many moles of that. Right? Use the given and know that molarity times volume always equals moles. So, because this is moles per liter, I'm going to say 0.0170 liters of HCl times 2.50 moles over 1 liter. That's going to tell me how many moles of HCl I have. Then, what's next? What am I looking for? Okay, now you can combine this into one step if you want to. We're going to go to moles of MOH, but we already know it's 1 to 1, so I can just simply say moles of M instead of MOH, because otherwise you could do 2 steps, moles of MOH over 1 to 1 over HCl, and then 1 mole of M for every 1 mole of MOH, but that's kind of redundant, so we can just say 1 mole of M for every 1 mole of HCl. Now, do I need to go any farther? What am I looking for? Molar mass, which is what? Grams per mole. I already know grams. I just need to know how many moles that is, right? So again, if you don't know what you're looking for, you're not going to find it. I know grams. Okay? I just need to find moles, so I can stop right there because that's what I'm looking for, moles. Because I need to find the molar mass is grams per mole, that's my initial question. What do I already know grams, so the thing I'm looking for is moles. Okay, so what we're working on is just a general problem solving, you know, how do you figure out what am I given, what am I looking for, how do I know where to start, how do I know how to set these up? Okay, that's what I'm really trying to stress for you. So what do we get when we do this? 0.0425
Yeah.
moles of M. So what do I do with that number then?
Put it under the grams.
Plug it in right here, right? So that's gonna equal 4.36 grams divided by 0.0425 moles. And that's gonna give you grams per 1 mole, 96.9 grams per mole. So then it says, well, which alkali metal is that? Well, you just come over here, you find, is there one that's close to 96? And is that really what we got, 96?
Yeah.
Yeah, I mean,
Would it be the mol B?
no, it's an alkali metal, so it's gotta be one of those. So I'm gonna go back and we're gonna check some numbers. Yeah, we're gonna check some numbers. 103? It still isn't. Well, do we get that? Does everybody get this on this one? .017 times 2.5, 0.0425, 4.36, oops, divided by 102.58, which still isn't any one of those, so, I know we did it right, the numbers didn't come out right, so I'm gonna say, and I'm gonna go back and double check here in a second, but I'm gonna say that that's a typo in the book. Okay, that one number's wrong somewhere, okay? So, cause I know that we did this right, this is many moles of this, that's gonna give me moles of that. We know it's 4.36 grams. The 100 milliliters of water really is irrelevant in this, cause it's not gonna change how many moles of my acid were present. And at the equivalence point, moles of acid equals moles of base, okay? It's not gonna affect how many, yeah. So, sometimes they give superfluous information. All right, so now, for the remaining of the period, I would like for you to try to do, now that's 85, 86 is very similar. So I'd like you to do 86. And I put a worksheet on Classroom to do as well, but I think I'm gonna save that and let you guys do the worksheet. I'm gonna change it and make the worksheet due on Wednesday, so you'll do the worksheet tomorrow at home. Just finish the problems, trying to do 86 through 88, 3 problems in the textbook right now. Okay? Alright, so the same thing for those of you who happen to be watching at home. So just use the rest of your time to work on 86 through 88. Those are going to be due today. The worksheet that's on there is going to be due tomorrow by midnight. And by the way, anyone watching this on YouTube, please feel free to subscribe to my page. Give me a like.